which I stopped partway through my little experiment. If you remember, what I'm trying to do, this is a picture of an EGR cooler valve, and there are two ways through the valve. The air from the EGR can either go through a cooler matrix, which is down here, or it can go through a bypass, which is here. And which way the air goes depends on this flap, which can either cover up the bypass or cover up the cooler. I was interested to see if my cooler was partially blocked, so I thought by trying to manually move this switch over, this flap over, I might be able to see the difference in pressure drop through the EGR cooler, and therefore indicate if there was the start of some problems. Things didn't quite work out that way. I switched the cooler off, I pulled a plug out, which controls a solenoid valve which operates the flap. And prior to doing that, I measured the airflow through the engine while it was in neutral, just revved it up from 0 up to 3,000 RPM up here, or 2,500 RPM, and then measuring the total airflow through the engine, the airflow through the mass airflow into the vehicle, that's fresh air into the vehicle, and the EGR flow. So that line and that line, add those together, and you get the total airflow through the engine as the revs are up and down. So that was done before I unplugged the solenoid valve. I tried again after unplugging the solenoid valve, and to my surprise, I wasn't expecting this, I found there was actually no flow through the EGR cooler at all. If you look here, this is the revs going up to 3,000 and then back down again. This is the total flow and the mass airflow doing exactly the same thing. So those two lines are on top of each other. And the EGR flow is down here. So essentially I created myself an EGR delete by unplugging that plug. So there was no flow through the EGR. At the time, there were no fault codes, there was a fault code, but there was no warning lights came on, and so I was a bit perturbed about that. And I also didn't know, well, in this condition, would the vehicle regenerate or not? So I've done myself a couple of little tests to see what's happened, and done a bit more investigation. What I found was that the fault code was 2425. Was logged immediately, and then this little warning light here, which is for the catalytic converter, came up after 3 or 4 engine starts. So there is a warning to the driver, and there is a fault code which would be sorted out later on, or seen, should I say, when you look through the fault log. So the main purpose of this investigation now is to look a little bit, see if we can get rid of this warning light and fault log anyway. Have a look at the DPF loading while the vehicle is in this condition, i.e. with the EGR essentially deleted. And then actually go back to the original problem, which will identify if I had any EGR cooler blockage. If anybody's interested, this is a list of materials that I use to do my little test. You can pause on that later if you wish. Right, so the plug I unplugged went into this thing here. This is it's on top of the engine, and it's an EGR vacuum solenoid valve, which is electrically operated. That's a plug that goes into it. I unplugged that plug, and so I thought, when in doing so, EGR flow went to 0, but the fault was logged and the lights came on. So I was just interested, well, is there some way of turning the lights off while the plug is still unplugged? So I measured the resistance of this connector, and it was about 37 ohms. So to be on the safe side, I plugged a 100 ohm resistor into there, and then I removed the fault code using an app. So there was no fault code there, and the light went off. And I started the engine, and lo and behold, the light didn't come back on, and there was no fault log. However, also the EGR valve was now working, because of course it's obvious when I think about it. The computer thought that this plug was plugged in there, therefore had no need to go into the fault mode. So it really didn't help plugging that resistor in there at all. A bit of a waste of time. Also, after a little while, that resistor got a bit too hot for my liking. So maybe something a bit larger in capacity would have been worth having. So to summarise, I couldn't find a way of turning the connector off. Sorry, turning the lights off. Okay, so the next step was to go out and see, well, with the EGR essentially deleted by unplugging that plug, did it actually reduce the SUP collected in my DPF? So this is a graph I've produced previously. Basically, this is kilometres along here since the last regeneration, and this is up here is SUP collected. Very early on, before the fix was ever applied to my car, I just measured continually how long it took the DPF to clog up, and I got these lines. And this is how it went. After the fix, there was a dramatic increase in SUT, and instead of doing like sort of 500 kilometres before having to regenerate, I was suddenly having to do about 150 kilometres before regenerating, and the lines were all sort of going up there. This is what I started measuring before I unplugged that connector, and that's about the point I unplugged it. And as you can see, the gradient of the line, follows really the gradients of more or less bang on what the car was before I had the fix. So it appears to me that we've really returned, at least from a SUP point of view, the vehicle back to the condition it was in before the fix. Well, a couple of other things I wanted to check was, well, yeah, when it actually gets to this point here, will it actually regenerate? And lo and behold, it did. It regenerated, and the SUP dropped back down to 5 grams again, and the whole cycle started again. And I'd actually chatted to some guy on YouTube, and he had the same sort of experience. So we're pretty sure that, yeah, unplugging that plug essentially deletes the EGR, puts a warning light on, puts a fault code in, but reduces the SUP probably about a factor of 3, and regeneration just carries on as it always did. So that's it. Long term, of course, I wouldn't necessarily recommend this, because we're not quite sure what long-term effects would be. You'd need to do some long-term tests to see if it carried on working like this, and if it did any other damage to the vehicle or not. But I think probably not, because everything looks pretty good so far. So now back to the original test that I was trying to do, which was checking if the cooler was blocked or starting to block in my car. My car's a 2-litre TVI Passat, 140 brake horsepower, 24,000 miles on the clock when it had the fix done. Current mileage about 28,000 miles. So what I decided to do was to put the plug back in. So reconnect the EGR again. So now the flow is going through the EGR and to the cooler. And then by using a vacuum pump, this is a kit that I bought, and connecting it up to the hose that feeds the actuator that actuates that bypass flap that I mentioned, I can manually pump this valve down, or not pump it down, and basically see what happens to the flow through the whole engine. And this gives you an idea. Again, similar sort of test. What I did here was started off with all the flow going through the cooler. So that means that there was no vacuum applied at all. That's like the default position. So no flow going through the cooler. This is the revs going up to 2,500 RPM. This here is a total airflow. This is the mass airflow into the vehicle itself, and this is the EGR flow. So that's what we're getting. I kept the engine running, and then I manually operated the piston, which moves the flap over, so that all the exhaust gas flow now should be going through the bypass. And I revved up and down again, and strangely enough, it made absolutely no difference. So I think that's pretty good, actually. That really shows that my car, that's got a relatively low mileage on it and hasn't done too many miles since the fix, has still got a relatively free-flowing EGR cooler, which is good. I then decided that I'd have a look at another vehicle, which is my son's vehicle, which is a 1.6 TDI. It's a Seat. I did the same test again. The graphs look a little bit different, but that's basically because it's just a bit of operator error, really. So the blue line here is the revs going up to 3,000 and down, and back up to 3,000 again. This portion here is all with no vacuum. The EGR is going through the cooler, and this portion here is with the EGR going through the bypass after the manually operated the vacuum valve. Pretty much same story. This is the total flow here. A little shocked to see that the total flow went down a little bit when I went through the bypass, which seemed a little bit strange. And also the EGR flow went down after I went through the bypass. Something that really did shock me though was this level here of total flow through the engine, both before and after operating that bypass valve. This graph is on the same scale as a previous graph, so if I show you them both together, this is my Passat, a 2 litre Passat. This is my son's Seat 1.6, and you can see that my mass airflow at maximum revs with and without the cooler is around 40 grams per second of air, where my son's is up at 100, no actually near 120 grams per second of air going through the vehicle, which is just doesn't make sense. You know, a smaller engine at the same revs you'd expect to take less air, and it's actually taking twice as much air. His vehicle's got 67,000 miles on it. It doesn't have a fix. And really, these measurements are irrational, and they need some explaining because it just couldn't happen like that. One obvious potential fault is that, of course, we know that the mass airflow meter on the 1.6 engine is not very accurate, which is the reason why they put this flow straightener on it. And that could be the reason that it isn't getting the correct airflow, and that's just screwing all the readings up. Which, if that is the case, it does make me wonder how the emission system at all ever worked properly on this vehicle, because, you know, clearly from this, it's got no understanding of how much air is going through, and it's actually telling me that it's using about 85% of EGR, which is way more than what's used here on the 2 litre engine. So that's something that needs looking into. So, right, conclusions. If you disconnect the EGR cooler vacuum switch, it causes the EGR valve to close and reduces EGR flow rate to 0. Fault code immediately locked. Catalytic converter light comes on after several restarts. This can be reversed with a fault codes reader, but a shunt does not fool the ECU into turning off the light or allow the fault to be removed. In this condition, DPF subloading rate reduces to about a third. Regeneration occurs as normal. Long-term reliability tests and real-world emissions tests will be required to establish the impact, and so really I'm saying don't try this at home. On the Passat, my Passat forcing the EGR through the bypass around the cooler made no discernible change to the flow rate, so I think that my cooler is pretty well free at the minute. It's not blocked. On my son's, really couldn't see much of a difference, but the results were irrational. It's saying that his vehicle takes twice as much air as mine, when really it should take half as much air as mine. So really, I think it's a very useful test that it's done. It shows some very interesting stuff. But what we really need to do is to test some more vehicles, get some more results, and sort of say, well, what is actually happening here? Because while doing this test, none of what happened was what I was expecting to see. We can only really find out what's happening by just trying things and recording things and seeing what the implications are. So that's